Hello. Hello. See, stream start ஆயிடுச்சு with a full குசுவா இருக்கு bro. Seriously. சும்மா போய் இப்போ ஃபேனை போட்டு வந்தேன். இந்த கொசுவெல்லாம் ஷூ ஆகிடும். So that I can go do some studying. 5:30 தான் ஸ்டார்ட் பண்ணுறேன். நைஸ். So I just have to study for like 1 hour. மொட்ராய்டா ஆன் பண்ணுங்க ப்ரோ, எல்லாம் யூஸ் பண்ணுங்க ப்ரோ, எதுக்கு எல்லாம் கேட்காதீங்க, சும்மா யூஸ் பண்ணுங்க. மேப்போ சவுண்டு ஓடும் தானே. கமாஸ் மீ ஓகே, ஸ்டார்ட் ஆகிடுச்சு. ஹலோ ஃப்ரெண்ட்ஸ், ஹலோ வணக்கம். இன்றைக்கி வந்து நம்மளோட இந்த எம்எல் தான் பார்க்குவோம் இன்றைக்கி மோஸ்ட்டாக. நைட்டு என்னோட ரன் பண்ணுறேன், கோடையே ரன் பண்ணுறேன், பாருங்கள். ஓகேண்ணா? ஓகே.
You have made problems. These are the top or the input.
வீடியோ சின்னதாக இருக்கா?
Memory. So for that you have this another technique called the stochastic gradient descent technique, which is what I just talked about, which is, imagine like you're on a hill and it's dark and you want to figure out how to go down. You just take steps in each direction, figure out which direction goes down, and then take a few steps in that direction and then repeat, right? So that's called stochastic gradient descent. You can check out these videos for some explanation of how these work, some mathematical explanation. In general, we are not going to look at it in a lot of detail because you will never have to implement these. It helps to understand them, but in general you won't and you can't really implement these. You will mostly have to depend on the libraries to do this, and the more important skill for you is to know how to use these rather than to understand the mathematical representation. But yeah, ordinary least squares works well for small data sets, uses some direct matrix computations. Gradient descent works well for larger data sets and uses an iterative approach. So here's a visualization of how gradient descent works. It starts out with a flat line and then it slowly improves both the weight. So you can see now it is improving the bias so far, but once it gets close enough, it's going to start turning the line. So it's going to start changing the line. So it computes the loss, it figures out whether it should increase or decrease the weight, it figures out whether it should increase or decrease the bias or the intersect, and that's how it keeps changing the line step by step, and then it gets to the very close to the best fit line. And it works really well for large data sets where you have millions or tens of millions of data points. So you will be applying linear regression to some really large data sets, and that's where you will get to see gradient descent in action. Okay, and it is actually quite similar to our own strategy of just gradually moving the line closer to the points. So that's what we are going to do. Now, in practice, you will never have to implement either of these methods yourself. You can use a library like scikit-learn to do this for you. So I'm going to install this library, scikit-learn. Scikit-learn contains functions, modules for doing machine learning with Python. It's one of the most used libraries in the world for machine learning. And we are going to start out by using the simplest function that it offers, which is the linear regression class. So let's use the linear regression class from scikit-learn to find the best fit line for age versus charges using scikit-learn. So I'm going to install pip install scikit-learn, all right, and then I'm going to import from scikit-learn the linear
உடனே டக்குன்னு பண்ணாதீங்க ப்ரோ, ஓகே? கொஞ்சம் வெயிட் பண்ணுங்க. what all is going on?
Regression model, the linear regression class. Haven't done anything so far. It's in the linear model section. Then we need to create a new model object. So we create a new model equals linear regression. Next, here's what happens. You call there, every model in scikit-learn has a fit method. And let's look at the help for the fit method. So the fit method takes some parameters and takes some targets, and it fits a line. In the case of linear regression, it fits a line between those parameters and targets. Okay, so that's what we're going to do next. We are going to fit the model to the data. Model.fit takes an x, which is the inputs, and this should be of the shape number of samples, which means number of data points we have, comma number of features, and in this case we just have one feature. But important thing is that this should be a two-dimensional matrix or numpy array. Then you have this y, which should be array-like, so it should either be a one-dimensional array, which is simply for each sample what is the target value, or if you can even predict multiple targets. Let's say you want to predict medical charges, you want to predict travel charges, you want to predict some other charges, so you can have multiple targets as well. In our case we have only one. Okay, so let's now create some inputs and let's create some targets and let's put them into model.fit. So here's what I'm going to do.
Die. ஸோ எப்படி எடுக்கிறானுங்க இன்புட் சார்ஜஸை? ஏஜ் ஒரு சாப்பாடு ரெண்டு வேணுமே. ஓ ஓகே 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 ஓகே. என்ன ப்ரோ என்னாச்சு? சைக்கிட்லன் ஸ்கை சை அப்படி ஆயிடுச்சா? இப்போ ஓகேவா மேடம்? ஓ மை காட், இது ஹெல்ப் பண்ணுறது அரே லைக்கா? n samples n features. ஹெல்ப் பண்ணலாம் சும்மா. ஸோ இப்போ வந்து நம்மளுக்கு இன்புட்ஸ் வேணும். இன்புட்ஸ் ஈக்குவல் டு smoker, non-smokers, that non-smokers of age, non-smokers ஓட ஏஜ், டார்கெட் வந்து யாரை டார்கெட் பண்ணுறோம்? இந்த லைனை தான் டார்கெட் பண்ணுறோம். non-smokersோட சார்ஜஸ். so மாதிரி பண்றேன் நான் so ஓகேவா ப்ரோ புல்தி மாதிரி என்னடா இதுன்னு பாரு ஓகே ஸோ வி ஜஸ்ட் லேர்ன்டு ஓகே புரியுதா நம்ம வந்து கற்றுக்கிட்டோம் அந்த மாடலோட ஃபார்முலா இருந்து நம்ம கற்றுக்கிட்டோம் அதை வச்சு நம்ம பண்ணியிருக்கோம் ஸோ ஓகே ஃப்ரம் சைக்கி லேர்ன் எஸ்கே லேர்ன் லீனியர் மாடல் இன்புட் லீனியர் ரிக்ரெஷன் This course is diabolical actually. This course is practical and hands-on introduction to beginners with basic knowledge.
From non-smoker DF, I'm going to pick age, but I don't want to just pick age. I don't just want to do this because this is going to give me a series, and this just has one dimension. Remember, model.fit requires 2 dimensions, so I'm going to give it a list of columns that I want to pick, and in the list I just want to put the single column age. Okay, so it's a subtle difference here that we don't want a series, we want a data frame. And if you check inputs here, inputs is a data frame, not a series. Like you can check type of inputs. Type of inputs is data frame, and inputs has the shape. Yeah, inputs has the shape 1064, 1. Okay, so it needs to be a 2-dimensional tensor. Very important. And the targets can just be an array. So in the targets are simply the charges. So non-smoker df.charges. And then we check the shape of inputs and we check the shape of targets. You have the expected shapes. So now this is everything that we've been building towards. This is the one line that does everything that we need to do. When we said model equals linear regression, we already mentioned to scikit-learn that we want to assume a linear relationship between our inputs and our targets, which means we want our targets, which is charges, to be some weight w multiplied with the age, which is the input, plus some number b. So now we're telling scikit-learn that hey, these are some inputs for you, and these are the targets for those inputs. Means these are some ages, and these are the charges for these ages. Can you please calculate the loss? So maybe first guess some random w and b, and get the predictions, compare the predictions with the targets, see how bad your predictions are, and then use a gradient descent algorithm or use some other optimization strategy to improve the values of W and B, and keep improving till you cannot improve anymore, and then give me the final result. So that's what happens when you call model.fit. So when you say model.fit, now inside model, a line has been fitted, which means a W and a B have been found, which make the
So we did this right. linear regression. ஆனால் செம்மடா அது ஆக்சுவலி இது ஒர்த்து ப்ரோ. ஏன்னா நீ வந்து எப்படி வருதுன்னு தெரிஞ்சுக்கிட்டப்போ இப்போ வந்து ஜஸ்ட்டு நீ இதை மட்டும் படிச்சுட்டு போயிங்கன்னு வச்சுக்கேன். லீனியர் ரிக்ரெஷன் ஒரு மாடல் வந்து அப்படியே என்ன நம்ம 2 வேல்யூ கொடுத்தோன்னா அது அப்படியே வந்து பிரிண்ட் பண்ணி கொடுத்துரும் அப்படின்னு தெரியாமல் அதோட ஃபார்முலா என்ன, அந்த ஃபார்முலாவில் எந்த 2 வேல்யூவை கண்டுபிடிச்சி மினிமைஸ் பண்ணிட்டே வருது, ஆர்எம்எஸ்சி எரரை வந்து கம்மி பண்ணிக்கிட்டே வருது அப்படின்றத அதெல்லாம் பண்ணுது. ஆர்எம்எஸ்சி எரர் வந்து கண்டுபிடிக்குது, டார்கெட்லேருந்து எவ்வளோ நீ டிஃப்ரென்ஸ் ஆகிறன்னு சொல்லி ஆர்எம்எஸ்சி எரர் வச்சு கண்டுபிடிச்சிட்டு அதுக்கப்புறம் அதை எரரை ரெடியூஸ் பண்ணுறதுக்கு வெயிட்டையும் பயாஸையும் மாற்றிக்கிட்டே இருக்கும். ஸோ அந்த வெயிட்டையும் பயாஸையும் மாற்றுறதுக்கு இந்த ஆர்டினரி லீஸ்ட் ஸ்கொயர் அல்காரிதமோ இல்லை கிரேடியன்ட் டிசென்ட் அல்காரிதம் 2 அல்காரிதம் ஏதோ ஒரு அல்காரிதம் யூஸ் பண்ணி ஸோ லைப்ரரி அந்த 2 அல்காரிதத்தை யூஸ் பண்ணி உனக்கு வந்து ஒரு கட்டத்தில் எவ்வளோ பக்கத்தில் அந்த எரரை எவ்வளோக்கு எவ்வளோ கம்மிப்படுத்தி லிட்ரலாக கிட்டத்தட்ட ஜீரோ அப்படின்னு வராதுன்னு நினைக்கிறேன். பர்ஃபெக்ட் மாடல் எக்ஸிஸ்ட் ஆகும்னு தெரியல. கிட்டத்தட்ட 95% 90% மேலே வந்து ஆன்சர் பக்காவாக இருக்கிற மாதிரி ஒரு மாடலை க்ரியேட் பண்ணிவிட்டு அவள்தான் இந்தாப்பா அப்படின்ற மாதிரி குத்துட்டுச்சு. ஸோ இதான்ப்பா எனக்கு என்னால் முடிஞ்சது அப்படின்னு சொல்லி இது பண்ணுது. இந்த மாடலை நம்ம வந்து இது எல்லாத்தையும் நம்ம தனித்தனியாக ஒரு வாட்டி நம்ம செக் பண்ணுறதுக்கு இந்த சைக்கிட்லனில் இருக்கிற லீனியர் ரிக்ரெஷன் மாடல் யூஸ் பண்ணலாம். நீ இதை ஜஸ்ட் நார்மலாக படிச்சிருந்தாலும் உனக்கு புரிஞ்சுது. இப்படி படித்தாலும் புரியும். பக்காவாக நடத்திருக்கிறோம். நல்லா வேலை இதை எடுத்தேன். ஓகே, ஸோ இப்போ வந்து நம்ம ஒரு வேல்யூ கொடுக்குறோம். 23 வயசு ஏஜ் தானே கொடுக்கணும்.
லாஸ் த மீன்
ஏஜ் தான் கொடுக்கணும். 23 வயது சிங்கிள் டைமென்ஷன் ஆரையில் கொடுக்காம ஒரு மல்டி டைமென்ஷன் ஆரையில் கொடுக்கணும். அப்படிலாம் இல்லை. வயசு ஒரு 37 வயசு, அப்புறம் ஒரு 60 வயசு. என்னோட 17 வயசு ஒன்று போட்டு 17 வயசு. ஸோ இந்த 4 வேலையை ப்ரெடிக்ட் பண்ணி சொல்லு அப்படின்னா எரர் வந்துடும். ஏன்னா அரே டேக்ஸ் என்ன சொல்கிற, அரே டேக்ஸ் அரே ப்ரெடிக்ட். ஓகே, இது எல்லாத்தையும் ஒரு இதில் லிஸ்ட்டில் போடணுமா? அதெல்லாம் பண்ணாதீங்க. X does not have a valid feature names, but linear regression was fitted with the feature names. X does not have a valid feature names, but linear regression was fitted with the feature names.
Mean squared or root mean squared loss, the lowest possible. So
why X does not have
and the loss is also coded inside the model. We don't need to worry about that either. But here's now what we can use it for. We can now make predictions using the model. So now we have a model, we have fitted our model. Let us try predicting the charges for the ages 23, 37 and 61. So we say model.predict, and then we give it this two-dimensional array. So in this two-dimensional array, we have a bunch of rows, and in each row we have just one column. So we have the value 23, this will be the value of age, another value 37, again another value of age, another value 61, another value of age. So we expect to get 3 values for the charges. So for this row,
என்னடா இதுக்கு மட்டும் கொடுத்துச்சு. இப்போ ரன் பண்ண நீ கொடுத்தது தானே நானும் கொடுத்தேன்.
So we expect 37. So we say model.predict, and 3 of them we can get the model between squared log. What happens when you call model.fit? So it's a W and a B have a root, we don't mod, keep a column and another value charges. So for this row, or for this age 23, the model predicts 4055. For this age 37, the model predicts 7796. For this age 61, the model predicts 14210. Okay, so it's starting to look good. Remember, when for smaller ages the cost is around $4,000, and then for the larger ages like around 60 or 64, it gets closer to 15,000. So it seems like our model has done a pretty good job. Let us maybe compute the predictions for the entire set of inputs that we have given the model. So what is our inputs? Our inputs are simply the ages, right? So you can see here, our inputs are simply the ages. So let's give a full list of all the ages, and let's see what the model predicts for all the ages. So this is what the predictions look like. And you can check what the inputs are and see if these seem reasonable. 18, 28, 33, 31. So for 8 that these people incurred. So the targets is the actual costs that these people. Incurred. So this person incurred a cost of 1725 and we predicted 2719. This person incurred a cost of 4449 and we predicted 5391. This person incurred 21,000 and we predicted 6727. This person incurred 2007 and we predicted 3520. So it's in the good range. It's not that bad. It's maybe off by 1,000 or so, but when you're dealing with values in the range of about 15,000 or so, the error of 1,000 is probably acceptable, right? And it's mostly on the higher side for lower values, which is fine too, because we know that there are a lot of outliers which are quite high in value. Okay. We can also look at the loss. We have this RMSE function, which is the root mean squared error. So with that, we will take the targets minus predictions, square all of the numbers, add up all the squares, take the average, and take the square root of that. Let's look at the RMSE. So the RMSE for this model, the root mean squared error for this model is 4662, which means on average we are off by about $4,600, and that's the average. But actually, when you look at the values, you'll see that you're off by much less. It's just that some of these are such big outliers that we cannot capture that relationship with just a simple line. Right? You can see that this one we should be predicting 21,000, but we get 6727, and it's simply not possible to get that far out of an outlier using a line. So on average, we're actually doing much better than 4662. We're probably in the 1,000, 2,000 range, but yeah, this captures the fact that there are a bunch of outliers in the model as well. So this is the whole process of machine learning, that you assume a certain relationship between inputs and targets, which is the linear relationship. You then find a loss, you find a way to measure how bad your model is based on certain random parameters that you've picked initially, and then you use some kind of
ஃபிக்ஸ் பண்ணுறேன்.
an optimization algorithm to improve the parameters of the model, in this case W and B, till you can minimize the loss. Okay. Optimize certain goals the far out already captured off, and that's the on take the square all of the number where we can also look at the loss. We have this RMSE function, which is the root mean squared error. So with that, we will take the targets minus predictions, square all of the numbers, add up all the squares, take
பெண்டாஸ் பைத்தான் எங்கடா எதுலடா இருக்கு மெஷின் லேர்னிங்கு. சரி ஓகே இது கேட்பாங்க. வாட் இஸ் சாரி ஆர்எம்எஸ்சி எரர்னு தெரியும். இது என்னது ஆர்எம்எஸ்சி எரர் வந்து இஸ் தேர் எனி built-in function which has RMSE. Is there any built-in function in scikit-learn which has RMSE? Import a mean square error. இதெல்லாம் சொன்னியாடா? இரு.
the average. RMSE for this model, the root mean squared error for this model is 4662.
Fuck you, really.
Which means on average we are off by about $4,600, and that's the average. But actually, when you look at the values, you'll see that you're off by much less. It's just that some of these are such big outliers that we cannot capture that relationship with just a simple line. Right? You can see that this one we should be predicting 21,000, but we get 6727, and it's simply not possible to get that far out of an outlier using a line. So on average, we're actually doing much better than 4662. We're probably in the 1000, 2000 range. But yeah, this captures the fact that there are a bunch of outliers in the model as well. So this is the whole process of machine learning, that you assume a certain relationship between inputs and targets, which is the linear relationship. you then find a loss, you find a way to measure how bad your model is based on certain random parameters that you've picked initially, and then you use some kind of an optimization algorithm to improve the parameters of the model, in this case W and B, till you can minimize the loss. Okay. So we've gotten to a good point. Our model is off by 4,000 on average, which is not too bad considering that there are several outliers. Now you may be wondering, where's the W and B? Well, in scikit-learn, the W is stored in model.coef. It stands for coefficients, which are the coefficients or the weights applied to each individual feature. In this case, we're just working with age. So we have 267 is the coefficient W. And then we have B here. Okay, so model.intercept contains B, and that is minus 2091. So it seems like if we had picked a W of 267 and a B of 2091, we would have gotten a pretty good line, and that would have been our best, that would have been the best possible model. So when you try this out later, see how close you can get without actually looking at the values of W and B. Let's maybe just plot them once again. So here we have all the points in blue, and here we have our model, our line showing the predictions. So you see that our line is fitting quite nicely. I won't say it's bad, and it's slightly above this cluster because we also want to somehow capture the fact that there are certain outliers at the top. Slightly above is fit out without actually looking at the values of W and B. Let's maybe just plot them once again. So here we have all the points in blue, and here we have our model, our line showing the predictions.
Try these illa.
So you see that our line is fitting quite nicely. I won't say it's bad, and it's slightly above this cluster because we also want to somehow capture the fact that there are certain outliers at the top. So if the line was somewhere here, it would technically not be giving the right information because it would not be suggesting the fact that there are outliers. So to account for all these outliers, it's slightly above the data. But that's pretty good. That's how you do linear regression using scikit-learn. You use the linear regression class, then you fit the model, and then you generate predictions on new data or on existing data. Now, the linear regression class uses this optimization technique called ordinary least squares. There is another technique called gradient descent that I had mentioned. For that, you need to use the SGD regressor. So I encourage you to try out SGD regressor. It works in exactly the same way. This is one of the nice things about scikit-learn. If you know how to use one model, you know how to use all the models. It's just that internally what's happening is different. So try out the SGD regressor.
First test பண்ணது my god, what? It's like predict
and train a model, make some predictions, compute the loss, and see if you see any difference in the result. Okay. One other exercise for you is to repeat the steps in this section to train a linear regression model to estimate the medical charges for smokers. So till now we've been dealing with non-smokers. So now you work with smokers and then visualize the target and predictions and compute the loss once again.
So that's it. இங்க விட்டா. சொல்லு நடத்து
Are you able to get a better model for non-smokers? What does that look like? Because for non-smokers, we seem to have these two clear clusters of data. So that would be worth figuring out. Okay. And that's it. Congratulations, you've just trained your first machine learning model. And machine learning is simply the process of computing the best parameters to model the relationship between some feature and targets. So every machine learning problem that we'll solve in this entire course, or in general that you'll solve anytime, will generally have three components. The first thing you will have to decide is how do you want to model the relationship? Do you want to model the relationship as a linear equation? Maybe you want to model the relationship as a polynomial equation. Maybe you want to model the relationship as some kind of a decision tree. Maybe you want to model the relationship in some other way. And there are many ways to model relationships. The simplest one is to just say that the thing that we're trying to predict, the target, is some kind of a weighted sum of the thing that we're trying to predict. The target is a weighted sum of the input features that we are interested in. For example, we could say that the charges is simply some weight W1 multiplied by age, some weight W2 multiplied by number of children, some weight W3 multiplied by BMI plus some number B, some intercept, right? So that's the model, and every model has parameters. That's what the machine has to learn. So to understand how good the parameters are of the model, we have a cost function, and there are several choices for cost function, but the idea for the cost function is that it should give you a cost, which it should give you how badly the model is performing, and the lower the cost, the better the model. Okay. Once you have a cost function that can be computed given some targets and predictions, then you need to use some kind of an optimization technique to optimize the cost, which means to change the parameters of the model so that it better fits the data. And this is what this entire process looks like. You put some input data into the model and you get some outputs. You take both the target and the output into the error or the loss function. You then apply an optimization method, and that optimization method changes the weights and biases, or changes the parameters of the model. So the model gets slightly better. Then you put some more input data, you get some more output. You take that, put that into the loss function, perform optimization, and improve the model. This, what we're seeing here, is essentially this animation that we saw here, which is taking a line and slowly moving it so that it perfectly fits the data, right? So most of machine learning and even a lot of deep learning is basically glorified line fitting. That's all we are doing. We are fitting lines, and the fact is that the only difference is we are saying that the relationship, instead of being a line, is something else, and we're asking the computer to compute the parameters in that relationship, or the parameters of that model.
Maja in
Okay.
green.
So that's machine learning, and as we've seen, it takes just a few lines of code to train a machine learning model using scikit-learn. You start out by creating some inputs and some targets. For example, in the inputs in this case are non-smoker DF, and we are just picking a set of columns. And currently, we're just picking one column, age. So the inputs need to be a two-dimensional array. Then you have targets, which can be one-dimensional or two-dimensional. So you have a list of inputs and a list of targets, and then you create a model. So here we are creating this model, linear regression, and most of the time, immediately you just want to fit the model. Not always, but most of the time. So if you just want to fit the model, you can create the object and immediately call .fit on it, and that will also return the model. So you can just do this, linear regression .fit, and into it you provide the inputs and the targets, and it's going to go and do its thing. It's going to do all of this for you. This class determines what kind of relationship you want to assume. Like here you want to assume the linear relationship, right? So you fit the data, and that gives you a model. Then you can use that model to make predictions. So now you can just take this model, and every time a new customer comes in, you ask them, hey, what's your age? And they say 32.
Huh?
and you put in the number 32 and you get a certain estimate for the medical charges. That estimate can then be used to compute their insurance premium and off they go. Right? So it automates that piece of analysis which you had to do with maybe using several experts with years of expertise. And there's a certain error. So whenever you use a model, you should be aware of what the error in your model is, or what the loss, the information loss in your model is. So in this case, what we say is that, hey, my predictions are off by maybe about 3 or 4,000. So you may just want to keep that in mind when you are calculating the insurance premium for this person. All right. And that's your 3 or 4 step process. Create inputs and targets, create a training model, create and train a model, generate some predictions with the model, and wherever possible, you also should have a measure of what is the information loss or what is the error in your model. So you create the input data and then you put that into some kind of a model, and the model gives you some predictions. Now you compare the predictions with the actual outputs, and that gives you some kind of a measurement how bad your model is. Your model is really bad initially. Then you run some kind of an optimization method, and that improves your model. So as you give some data into the model, it learns from the data, it makes better predictions. Then you give it some more feedback using the loss function, it makes a better prediction, and it gets better over time. If you can just grasp that basic idea and see how it is translated into code here, that is enough to get started. And it is a fundamentally different way of thinking about problems. If you are struggling with it a little bit, that's okay. Once you struggle through it and once you get the idea, once it clicks what's happening here, you will suddenly realize the potential of what it makes possible. Because now, instead of, let's say, having several years of expertise in analyzing or evaluating insurance applications, you just have this one system, you just feed in some input and it's going to give you an output, and you know how much it is going to be off by, and you can use it. What about some of the other features? So far we've used is the age feature to estimate charges. Adding another feature like BMI is very straightforward. So we simply assume this relationship now. Instead of saying charges is some weight W plus B, now we say that, hey, for calculating the medical charges, we give some weight to the age and some weight to the BMI. And then we have this other intercept term, which is simply to just move the line up or down. Of course, now this is no longer a line. It's linear in the sense that there is still a linear relationship. We're not doing squares or cubes or anything. But this becomes now a plane in 3 dimensions, essentially. If you put age, BMI, and charges on each dimension, this becomes a plane in 3 dimensions. So now we are working with a plane. But it's still called a linear regression. It's simply a linear combination or a weighted average of the age and BMI, the charges. So how do we apply this in code? The exact same 4 steps: create inputs and targets. So the inputs are, from non-smoker DF, we take age and we take the body mass index, and then the targets are simply the charges. The only change we made here is this: the way to train the model and create
That is the terminal. எங்கடா அது? டெர்மினல் இங்கே தான்டா இருக்கும். நானே ஓப்பன் பண்ணிடுவேன்டா. எங்கடா அது? டெர்மினல் கொடுங்கடா. என்னடா MongoDB டேட்டாபேஸ் SQL டூல்ஸ் என்னென்னமோ வச்சுருக்குறேன். நியூ டெர்மினல் வந்துட்டேன். அண்டு guys,